for lesson 10, and this is more of the applied stuff now. What you have to be really good at this is using the slope formula. Understanding if you have two values or 2 points, you can figure out what the rate is. Okay, that's why it's called rate of change. So we're going to go through 4 or 5 examples here of applied things in which you're going to find the rate of change. The weird thing is you understand what that actually means, that number. So let me show you what I'm talking about. So see, complete the following and calculate the slope of this line. So we have 2 points. We can calculate the slope of that line. Okay, so let's do that first. So we're going to go 120 minus 40 over 3 minus 1. So that's going to be 80 over 2, which is 40. Okay, so let's read the chart, though. The chart says the graph shown represented by the distance traveled by a car is a linear function of time. So the time you drive equals the distance you go. So what does this number represent? 40 what?
40 kilometers per hour.
Exactly, 40 kilometers per hour. Okay, and that's obviously it's right here, but it's 40 kilometers per hour because that is your rate of change. You're going 40 kilometers per hour. You figured that out by using the slope formula for the rate of change. Okay, so 40 is the slope of this line. Okay, so for example here, watch. If I go up 40 and I go over 1, that's going to be 280. If I go up 40 over 1, that's going to be 3,120. That's how it's growing. So the next one would be 4,160. It'd keep going up by 40 every time, for every hour. Okay? Any questions with that? All right, let's keep going here. Okay, warm number 2. The graph shows represents the temperature of an oven is a linear function. So when you're heating up an oven, calculate the slope of the line again. Okay, 350 minus 50 over 5 minus 0. 300 over 5 equals 60. 60 what? Someone said Dickie. 60 what, Jake? 60 degrees Fahrenheit per what? Minute. So that means this oven heats up 60 degrees per minute. That's what you just figured out. Okay? So at a rate of 60 degrees Fahrenheit per minute. That's the rate of change. Any questions? Just doing slope formula. Doing slope formula, getting that answer, and understanding what that answer represents. Temperature is a function of time. Okay. Here we go. Next one. I'm going to keep going if I'm not getting questions. So if I'm going too fast, I need to ask questions. Some of you guys are mailing in already. I know it's Friday, but let's finish. This is the last one for the unit. Okay. The graph shown represents the amount of fuel in a gas tank as a car as a function of distance traveled. Notice this line is what? Negative. So we have a negative relation here, which makes sense because as you drive, you lose gas. Okay, so as you drive, you're losing gas. So calculate the slope of the line. So 40 minus 50 over 120 minus 20. 40 minus 50 is negative 10, which makes sense. We're expecting a negative slope. 120 minus 20 is 100. That reduces to negative 1/10. So what does that mean? Every kilometer, you lose 1/10 of a tank. Okay, of 1/10 of what you have. Okay. So change the amount of fuel. So what unit? So the amount of fuel in the tank is decreasing. The rate of change of fuel in the fuel tank is negative 1/10. liters. Yeah, you lose negative 1/10 of, sorry, it's negative 1/10 of a liter per kilometer, not the tank, sorry. It's in liters. I said that wrong. So you use 1/10 of a liter per kilometer, which makes more sense. If you lost 1/10 of your tank per kilometer, that would not, yeah, you would not go very far. Moped would be bigger. A moped would still be higher. Like a Hummer would be more of a problem. Yeah. Mopeds have really good gas mileage.
No, I'm saying if you got lots of weight on it.
Still has, we have better gas mileage than most cars.
You wouldn't be able to go anywhere.
Well, yeah. Okay. So what we're going to do now is, guys, we're going to tie it together. We're going to determine the equation of our line. In terms of determining the equation of our line, what are we missing? We're missing the starting amount, which is the b. That's correct. Okay. So y equals negative 1/10 x plus b. Refocus, refocus.
I did knock that one over.
No. We're missing the b, is what was said in all that commotion. The b represents how much gas you have in your tank to start. Okay, because that's your starting amount. Okay, so that would represent a full tank. So what we're going to do is, we're going to steal an x and a y from one of our points. I'll take the smaller numbers. So 50 is the y, negative 1/10 of 20 plus b. And I'm going to solve. 1/10 of 20, if I times those, that's 20 over 10, which is negative 2. And then I add the 2, and now you have b. I'll slow down. Negative 1/10 times 20 is negative 20 over 10. Negative 20 over 10 is negative 2. That's where the negative 2 came from.
So a full tank, you have
52 liters is a full tank.
And that would work with any. Okay.
Okay, so then our equation, the way they have it, n equals negative 1/10 d plus 52. So n means number of liters, negative 1/10 times the distance plus the 52. How this makes sense? If we travel 0, how much gas do we have? 52, right? Which makes sense, because that's how much is in the gas tank when it's full. Okay? Distance of 0. Okay? All right, keep trucking here. All right, so Tyrone's paid a base salary per week plus commission for selling electrical appliances. Last week his sales totaled $3,500. He earned $620. This week he earned $680 for selling $4,250. On a grid, plot the pairs. So they're telling us sales is our X, earnings is our E. So I'm going to go ahead and go by hundreds for my earnings. Okay, and for my my sales, I'm going to go by 1,000. Okay, and we're just going to roughly plot the points. Well, what points? Well, the points are, if sales is our X, that means these big numbers are X. 3,500 gives me 620. Right here. And then, see here, 4,250 gives me 680. So we're going to plot those on our grid there, part A. So 3,500, right about there. 620, right about there. 4,250, just after 4,000 here, up to 680, just under 700. So there is our points there, kind of the relation. So now we're going to calculate the slope. We have 2 points, so we're going to calculate the slope. 680 minus 620 over 4,250 minus 3,500 gives me 60 over 750, okay, which I think gives me 0.08. Can anybody understand or tell me what that represents? Yeah.
He earns 1,000 of price that he sold.
You're really close. That's his commission.
So he earns that
8% commission. 0.08 is 8%. So he gets 8% commission on what he sells. That's what we just figured out. So that's his growth, because he gets commission on what he sells. So, if you guys ever get to be a bartender or a waitress or a waiter, you get paid a flat fee of $10 an hour, no matter what. But if it's a holiday weekend, you're going to kill in tips, so your tips are going to be higher. Okay? So this is the same type of thing. Probably around Christmas, Tyrone's probably going to make more money. He's going to sell a lot more appliances, most likely. Okay? So explain what this graph represents. He has 8% on commission. Okay? State as a percent. We just did that. Calculate his weekly base salary. So what does that represent? So right now, we know our equation is this. His base salary, does that ever change?
Yes.
It's your y-intercept. His base salary never changed. How much money he makes total changes based on commission, but his base salary doesn't change. So he's always going to make $2,000 a week, let's say. Let's say he always makes $2,000 a week, but however much he sells is going to add to that. It's his bonus. Okay? Yeah.
How does he automatically make $2,000?
I made that number up. We're going to see how much he makes. No, we're going to plug in our points. We're going to put 40. We're going to put 680 here. I'm going to put 0.08 times 4250. So can somebody tell me what's 0.08 times 4250? 280? Okay. So that means 480 equals 280 plus B. So we minus 280. B is 200. Oh, 680, sorry. Thanks. Sorry. Thank you. So that means 400. Yeah, don't blindly follow me. So B is 400. So the money he makes base is 400. Okay, so if you think about that, that means he had $400, he got base, and then 680 is how much he took home, so he had 280 bonus for that week. Okay, any questions on that? All right, so his weekly base salary, we got that. That is the 400. How does the answer relate to this graph? That's the starting point. So if our graph kept going, it would start there, and he grows, so how much he sells is from there. So if he sells nothing, he's going to get $400 that week. Okay. All right, so let's do the last few questions. Let's see on the next page. So write the equation. So the equation then is earnings will be 8% of his sales plus 400. So what would we do to figure out how much? So 2 weeks ago he earned 486. How can we figure out how much he sold? How can we solve for X? Andrea? Yeah, put it for. Yep. Okay, and then what? Right, minus the 400, divide the 0.8. 0.08. So we have 86 equals 0.08 S. Make sure you do the 0.08, not 0.8.
Oh, yeah.
Yeah. 1,075 is how much he sold, which was pretty low compared to the other ones. Okay, all right, we're in our last section here. Okay, John is taking part in a long-distance car race. After 3 hours, he had traveled 270 kilometers. After 6 hours, he traveled 630 kilometers. On a grid, plot the order pairs. All right, so we got to go ahead and scale again. So is hours X or is Y X? That didn't make sense what I just said, but yes. Yeah. Hours is your X. Distance is your Y. Okay, so I'm going to go every 2 here. 1, 2, 3, 4, 5, 6. And I'm going to go, we're at 270, so I'm going to go by 50s. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Okay. Oh, we got to get to 600, and then 650. Okay. So I'm going to plot those. So I have the point 3, 270. So 3 is right there, 270 is right here, just above 250 for mine. Again, you can scale however you want. That doesn't make it wrong. 6 and 630. 630 is right about there. Okay, we can join those now so we can kind of see the linear relation of these two. Okay. All right, so let's calculate the slope of those. So we're going to do the slope of those now. So 630 minus 270 over 6 minus 3. $360 over 3, which is 120 kilometers an hour. So that means the car was going 120 kilometers an hour. Okay. The slope of the line segment represents rate of change. The rate is the average speed between the 2 points. State the average speed of the car between 3 hours and 6 hours. So we already said that. It's 120 kilometers an hour. On the grid, plot the point 0, 0, and determine the speed of the car during the first 3 hours of the race. Okay, so we're going to go ahead and do the slope between the first two. So that'd be this guy and 0, 0. 270 minus 0 over 3 minus 0. We got 270 over 3, which is 90. Why did it change? Can you think of a realistic reason why it changed?
Maybe it was curvy.
Yeah, that could be one. There's another kind of major thing. No, what's that? Yeah, he starts 0. He starts at 0, right? So, like, he's not going to just turn the car on and be going, boom, 120, right? So he's going to have to accelerate for a bit and then get 120. That's why he's going at a stable speed here, but then here it kind of bends a bit, like he kind of said, because he's going to accelerate. And, I mean, winding turns could definitely change it. Okay.
That's what I'm wondering. 3 hours.
Take it 3 hours to what? No, that's not true. It's because it really could just be like 1 hour, but like his average here could be like 45, and then he's like 120 here. And so that just makes that come down to 90. Right, he's not going 90 the whole time. It doesn't take him 3 hours to get to 120. It takes 3 hours for the average to be 120 almost. So like even if we average the ends, let's do that. We did this in the last class. Let's do that. Let's see what's the average over 6 hours. So 630 minus 0, 630 over 6, right? What's that going to be? It's not quite 120. 105. So see what happens is it's like it's getting closer because it's leveling out. Okay? That's good little investigation there. Building the grid. You can tell because I know it's harder on ours, but this is a little bit flatter. Okay? It's a little bit flatter line. If you're whoops, bit 2 T's. Okay, so like that means like kind of if it's going steeper, that's faster, but if it's going a little bit flatter, okay, in terms of angle, it's going to be slower. Okay, and that is it for these notes.